and we'll get started. Okay, so if you're seeing my screen, we have previously done a number of problems that are just what's inside the box there. Like you've seen problems where you have to factor what's inside the box.
Yeah.
Does that look familiar to you?
Yeah.
Okay, so the idea here is that to solve this equation, you are going to first factor, which is why you learned all those factoring techniques. Okay, so you're looking for two numbers that multiply to 6, positive 6, but add up to positive 5. So two numbers that multiply to 6 but add to 5, what would those be?
2 and 3.
2 and 3. So this becomes x plus 2, x plus 3 equals 0. Okay, so that's the first part. The next part here is to set each term equal to 0. So what I mean by a term has to have an x in it. So this in parentheses is a term, and this other one in parentheses is also a term. So you write without the parentheses x plus 2 equal to 0, comma, x plus 3 equal to 0. And these are just basic linear equations. These are things that you already know how to solve. Okay, so you subtract 2 from both sides to solve the first one, subtract 3 from both sides for the next one, and that's your final answer. All right, so we're going to do another one like this. We're going to do number 4. But these are the two steps. Like there's nothing more than this. Now factoring could be any of the types of factoring we've talked about, but the same sort of broad step, the broad things, generalized things we're doing here, you will be factoring the left-hand side. Okay. So on the left here, again, this is a plus plus. This is the good case. These are the nice ones. So you're looking for two numbers that multiply to 13, but add to positive 14. Can you tell me what those would be?
I feel like there's not in numbers that multiply to 13. It's one of those.
You always start with 1.
Yeah.
And then, are you okay?
Man, I hate when that happens.
Well, I missed that, but I hope you're okay. That's the main thing here. 1 and 13. So you always start with 1, 13. And if you can, you go to 2, 3, 4, 5, 6, 7. But in this case, because 13 is prime, that's the only possibility here. All right, so 1 and 13, do those add to 14? Yes.
Yes. So
you're right, y plus 1, y plus 13 equals 0. So that's first one. First one's correct. And then from here, you said each of those equal to 0. Y plus 1 equal to 0. Y plus 13 equal to 0. What would the two values of y be in this case?
Y equals -1 and y equals -13.
Any questions on that before we move on to another problem?
No.
Okay. So I'll try and go through the types of factoring kind of in the same order that we've been doing them in when we learned it the first time. May or may not be possible here. Of course it's not. All right. So we'll just have to go back and do them in basically the order they're presented here in. All right, so number two here, we'll look at next. All right, so two numbers now that multiply to -18, but add to -7. So you've seen me do this over and over again. You write the number on the right, the c, if you will, ax squared plus bx plus c. That c value is always over here on the right. And you start with 1 and -18, okay? And when it's negative, though, you have to flip the signs, because to get a negative, one's positive, one's negative, but it could also be -1 and 18, and so on here. So I'd like you to continue with this list until you come up with the one that adds up to -7.
Is it 2 and -9?
It is 2 and -9, yes. So it'd be x plus 2, x minus 9 equals 0. All right, now you're going to set each of these equal to 0. Okay, so you're going to subtract 2 from both sides. X equals -2. Add 9 to both sides. X equals 9.
Yep.
All right, so let's have you try one on your own from start to finish. If you have questions, please ask, but it's going to be the same. You're going to first factor. You'll set each of those terms equal to 0 and solve for x. So basically, I'm looking just like the worksheet shows. There are two answers for x at the end. Let me know what you come up with.
Yeah, x equals 2 and x equals -10.
Sounds right. So another way to check these is to actually put the numbers in for x. We haven't talked much about checking your answers, but this would be one way to do it. Basically, you put those numbers in for x. Notice when I substitute, I do it in parentheses. So that would be 4 plus 16 minus 20. And it's a question. It's like, does this equal 0? Is 4 plus 16 minus 20, does that equal 0? Yes, it does. Okay, and then we can do the same thing for the other one, -10 squared plus 8 times -10 minus 20 equals 0. 100 minus 80 minus 20, does that equal 0? And it does. Okay, now you don't need to check these, but this is a way to know if your answers are correct. Any questions on that?
No.
All right. Do you have other stuff that you need us to work on today, or is this, does this everything, just this 1 through 14?
Yeah, it's everything from the new unit,
Okay.
or not really,
Got it. Okay.
not incredibly new.
Yeah, I would say so. So 5 and 6 you can do on your own. Let's move to 7, and just because I don't want to just use up all our time on problems that you might already know the answer to. So let's look at number 7 here. All right. So this one says h squared plus 10h equals minus 21. If you look at your screen, or if you got it printed out there, number 1, 2, 3, 4, 5, and 6, they are all equal to 0. They all say equal to 0. Numbers 1 through 6 equal to 0. This one is not equal to 0 though, which means that you want to make it into one that does equal 0. So the first step here is to add 21 to both sides. H squared plus 10h plus 21 equals 0. All right, so if it doesn't equal 0, you make it equal to 0. I'd like you to solve this one out from here, and then we'll move to some new problems after this.
I got h equals -3 and h equals 7 or -7.
Yes, -7. Very good. Okay, so I feel like you got those down, which is great. All right, so on to some new stuff. So we'll look at number 8 together here. So just as a review here on terms of like the type of factoring that you will see, that list is greatest common factor, then it's difference of squares, then it's generally a perfect square trinomial, then it's a equals 1. We've been doing a bunch of those today. And then this one is the a not equal to 1, or what's called grouping. And that's the next one here. All right, so the step here is to take the 3 and multiply it by the 10. And that's when it's this grouping. So now you're looking for two numbers that multiply to 30, but add to -11. So since this is positive and this number is negative, -11, they're both going to be negative. So it's like -1 and -30, -2 and -15, -3 and -10, -5 and -6. So you have to be really comfortable with going through this list. All right. Now, do any of these add up to -11?
-5 and -6.
Yeah, so we got our winner there. Now we have a choice. Remember, we're breaking this one apart. We can write -5n minus 6n, or -6n minus 5n. But remember, you're pairing it with the 3n squared. So which do you feel like pairs better?
-6.
Yeah, so we're gonna use that second one there. I would agree. So we've got grouping here. We've got meaning you find the GCF between these two factors here. So we've got 3n goes into both. And if you recall, you have to divide both of those by 3n. So you're dividing each by 3n, each by 3n. Okay. What goes in parentheses?
N minus 2.
Okay.
Yeah.
That immediately goes over here to the right, and you figure out what goes in between.
Minus 5.
Very good. And you then double factor or factor again here, 3n minus 5 equals 0. So now you set each of those equal to 0. So you set n minus 2 equal to 0, 3n minus 5 equal to 0, and you solve each of those for 0. Can you give me the final answers for each of these?
Sure. 3n equals 5 and n equals 2.
N equals 5 divided by 3. You're going to add 5 and divide by 3, and then n equals 2. So you
Okay.
add 5 first. 3n equals 5, and then you have to divide by 3.
Okay.
All right, we'll do another one together here. So let's look at number 10. I'll have you do 9 on your own next, but 10's got that little additional step where you have to set the problem equal to 0. It always has to equal 0 when you're using one of these factoring techniques. So subtract 12 from both sides. 2m squared minus 5m minus 12 equals 0. This time you will multiply 2 times negative 12. It's the whole number. 2 times negative 12, negative 24. And here you need two numbers that multiply to negative 24, but add to negative 5. That means one's positive and one's negative. And you just start building your list. And then the last one here, 4, negative 4 and 6, 4 and negative 6. So do any of these, and you're always asking yourself this as you go, like you stop when you find one, do any of these add up to negative 5?
Positive 3 and negative 8.
Yes. So our choice again is like, well, which one comes first? Is it going to be 8m plus 3m or 3m plus 8m? And you kind of look at this first number, and I think you'll agree that it should be minus 8m plus 3m, because 8 pairs a little bit better than with 2. But
Yeah.
both are correct. Like there's not a wrong answer. It's just what do you prefer? All right, so this factor by grouping. So there's a 2m that goes into both. So go ahead and tell me what goes in parentheses there.
m minus 4.
Okay, very good. You immediately write that over here on the right. And then in that space holder there, position here, you figure out what goes in there such that when you multiply in, you get back to the previous line. Be plus 3.
Yeah.
So then you factor out the m minus 4, whatever's in parentheses. You grab the other ones. And then you set each of these equal to 0. Set each one equal to 0. M minus 4 equals 0. 2m plus 3 equals 0. So go ahead and solve those for us, and let me know what you come up with there.
I got m equals 4 and m equals -3/2.
Very good. And so this problem illustrates a combination of things. You have to remember to set equal to 0. You have to remember the type of factoring we're doing, and then you have to set each of them equal to 0. You know how to do each of these individually. It's just putting it all together, as they say in the classroom there. So I'd like you to try number 9. And as always, if you're not sure, have questions, please let me know. And just give me your final answers here whenever you have, and take your time here. We got plenty of time today. I mean, we will be able to go through almost all of these, but good practice here for you. See if this works.
I got x equals -1 and x equals 1/2.
Okay, so the -1's not too bad to test here. -1 squared minus 7 times -1 minus 9, does that equal 0? So -1 squared is 1, 2 times 1 is 2, plus 7 minus 9, that does in fact equal 0. So this is where kind of the limitations of trying to use this method where you put the numbers back in isn't all that good. You have to be really comfortable with fractions, which, you know, if you're like most students, you're not sure. Now you said it's positive 1/2, is that right?
Yes.
Okay. There looks like there could be a small issue here. Any chance you meant something else? What did you get for your FOIL? 2x and x, what did you get here?
I got 2x minus 1 and x plus 1.
There's no 9 anywhere.
Oh,
Should be a minus 9
I see it now.
and x plus 1.
So that becomes 9 over 2?
Yes.
Okay.
And that's, you know, even more difficult to work out here, but yeah. All right, let's do just keep going here. Let's do 12. We'll do 12 here. All right, so just like the other problems, you cannot have that constant on the right. You have to move it over. It's 5x squared minus 17x plus 6 equals 0. There is no greatest common factor, like there's no number that goes in all three of these. So you do have to do the grouping approach. So you have to take that 5 and multiply it by 6, and that is 30. So two numbers that multiply to 30 but add to negative 17, they're both negative. You build your list -1, -30, -2, and -15. You can stop when you find the right one. Like I know that, you know, I like to keep going just for completeness, but if you know the answer, you don't have to keep going. So 5x squared minus 15x minus 2x plus 6 equals 0. I'm choosing the minus 15 first because it goes with 5. Why don't you try working it out from here? And just keep in mind your grouping again, just double check all your signs and stuff.
All right. I got x equals 3 and x equals 2 over 5.
All right, so you should get 5x, x minus 3, x minus 3, and then minus 2. That looks good there. You're going to get x minus 3, 5x minus 2. Set them both equal to 0. And you've got it perfect. X is 3, x is 2/5. Very good. All right. So for some reason, 14 is the only one that is a GCF. Like, I guess teacher maybe ran out of options, or they just wanted to throw a weird one in at the end. This is a GCF though. And it's a GCF because you look at all the numbers and you say, okay, well, is there a number that goes into all of these? It is 2. Okay. If you don't do the GCF, like if you forget and you end up taking 2 and multiplying by minus 64, that still will work. You're just creating more work for yourself. So if there's a GCF, always factor that out. So in this case, it's x squared plus 4x minus 16 equals 0. And now you're back to problems like we were doing in the beginning of the lesson. Okay, meaning problems that where you're looking for two numbers that multiply to minus 16 but add to positive 4. So you could make that list if you wanted. Sorry, 4 and negative 4. And you should notice that none of them work, which is very frustrating. Do you see that none of these work? I've gone through the entire list.
Yeah.
So it's like, well, what do you do here? Well, when you can't factor, what always works? Do you remember from we did a little bit last week? What always works when you're solving a quadratic?
The quadratic formula.
Yeah. So that's the ax squared plus bx plus c equals 0. We unfortunately do have to do that in this problem. So a is 1, b is 8, and c is minus. You know what? I messed this up though. That's why I was like, why this shouldn't work. That's 32. So that's why this wasn't working. Oh man, I'm sorry. It's one of those days. Not going all well. Okay, so this is, yeah, and I was shocked. It's like, well, these have all been working. This one does work now. It's -2 and 16, 2 and negative 16. And there it is. Okay, you're like, okay, now I've got it. So you factor x minus 4, x plus 8 equals 0. And I mentioned this earlier. I said you set the x terms equal to 0. And this what I've bracketed in here, and this also, those are x terms. The 2 is not an x term because there's no x. Do you see that there's no x? Like there's nothing written. So you ignore it. But you still set the x terms, x minus 4 equal to 0, and x plus 8 equal to 0. So x equals 4, and x equals -8.
All right.
All right, so let's go back and have you try 5. I'll have you try 5 because these are the easier ones. Let's get as many of these that done as possible here. So this is kind of like the factoring we're just doing inside parentheses. It's the two numbers that multiply to -10, but add to -3. Okay. So why don't you work that one out and let me know what you come up with.
All right. I got C equals -2 and C equals 5.
Okay, so sounds like you got C -5, C +2 equals 0, and those are correct. Very good. All right. Wait, did I miss some? Oh, I did miss some. Okay, we should have gone a little bit further here. I apologize. Let's go to number 16 here. We'll do this one together. All right, so here we go. So number 16, we've got GCF again. Okay, so like finding a number that goes into 20, 82, and 80. So you might start with like just 2. You might just check, well, does 2 work? 10d squared minus 41d plus 40 equals 0. And then you say, okay, well, is there any other number that goes into 10, 41, and 40? 41, I believe, is prime. That's, you always kind of look for the one that sticks out, and that's this one. Okay, so this is as far as you can go, and this is where it gets like kind of frustrating, because you got to take 10 and multiply it by 40. So 10 times 40 is 400. Wow, yeah, big numbers. So we're looking for 2 numbers that multiply to 400 but add up to minus 41 here. This is where you just make your list. They're both negative. You're -1 and -400, -2, -200, -4, -100. Okay, -5, -80. 6 does not work. 7 does not work. 8 does work. -8 and -50. So notice we're getting closer each time. Now you might think, well, why don't I just start at those in the middle? You can. You just got to be careful that you don't miss out on any of these. Now, did I actually do this right? Yeah, it looks okay. All right. So the problem here is, what do we do after 10? Does 12 work? 12 works if 2, 3, and 4 work, which we don't have here. 3 and 4. 14 doesn't work, but does 15 work? So we start looking for numbers that's probably why you're allowed to have a calculator on a problem like this. 15 does not work. Do you get the answers to these?
We do not.
Do not. Okay, let me check this one online real quick, because this one's looking like it won't work, and I'm really surprised that they would give you one that didn't work here. So of course it does work. Did I miss this? I must have missed it going through the list. 10, B1. Huh. Sorry, I'm just struggling. I don't know why we're not able to find the ones that work here.
400 is a big number.
Yeah, and this number is not right. 400 divided by 8 is 50. Let's see here, 12. Okay, so here, so it took me a while here, but it does work. 16 works, -16 and -25. It is frustrating even for people do this all the time, because it's like, where is the number? That one does work. So it's 10d squared minus 25d minus 16d plus 40. And from here, you do the grouping like we've done a bunch of times here. So you look at the first 2 terms. Is there a number that goes into both of them? Yes, it's 5d And that becomes 2d minus 5, 2d minus 5. This 2 is still on the outside. You're kind of think of it as brackets there. You've got to figure out what goes in this missing position, which, so you're looking back at that previous line, looks like it's 8 minus 8.
Yeah.
So now it's 5d minus 8 times 2d minus 5, and this 2 comes down here for that. So this is, you said 5d minus 8 equal to 0, 2d minus 5 equal to 0, and you solve each of those. So d is 8 over 5, d is 5 over 2. Let me know when you get all that down. The time we have left, I'd like to go through what each of these are, so you've got a plan of attack for them.
I got it.
All right, so I believe we did not do 6. 6 is an a equals 1. It's like 1 through 5. I don't believe we did. We did 9, we did 10. Have we done 11? 11, 12, and 13 are all grouping. 15 is grouping. 17 is grouping. 18 is grouping. These are all grouping. Okay, I think that takes care of all the ones we did not get to today. So I know a little bit left to do, but you do know how to do all of these. Just maybe have to go back and take, practice a little bit for that. Okay, so we'll go ahead and stop.